Hi friends, in this video lecture, let us discuss more on the aircraft performance. In the previous video lectures, we have seen about minimum drag, also about we have all the numericals on based on the minimum drag conditions. So in this lecture, let us discuss about power required. So power required, is very important. We'll just see how yes. So power required. So power required depends on the thrust required, because power is generally comes from the thrust. So or we can just say that power we are obtaining multiplying the thrust with the velocity. So we'll just see generally thrust required is a very important one, because thrust required is it is required, thrust is required to overcome the drag produced by the aircraft. So because especially in the steady level flight we have to because in steady level flight we say that lift equal to W, that means lift equal to weight and thrust equal to drag. So if you want to achieve this condition, then thrust required should be equal to the drag. So whatever the thrust required, that is to overcome the drag produced by the aircraft. So now the thrust required, as we have seen that it is thrust required is nothing but we can just say it is equal to drag. So to overcome the drag. So now power, that means this, because we know thrust required equal to drag, then drag, we all know drag equal to, so the equation we have seen. So this is nothing but what to say, in our previous lectures we have seen that half rho S CD naught, CD naught into this is half rho CD naught into V square plus K W square by rho S into 1 by 1 by V square. So this is what, because generally these terms just we used to take it as the A, this term is to be taken as A, and this we used to take it as B. So once we know A and B, so we can just calculate, we can find out what is here just we are missing one term, that is nothing but 2. So we can just, we have to take 2k this one. So we can just say 2 this one. So this is we can say B, this is A and this is B. So this is what drag. So when we say power, nothing but we have to multiply with the velocity. So power nothing but we are just power equal to, we are just multiplying the drag into velocity, because so now we have got the drag equation. Then with that, now we are multiplying with the velocity. So when we do so, then what happened here also, because here in the left hand side here we are multiplying, then right hand side also here we have to multiply. So already here v square. So now if we are multiplying with the v, then it will become v cube. So it is v cube. Then here we are multiplying, so v by v square. So this will become that means we can just say v, this will get cancelled, so only v. So it means now what happened, power equal to our this equation a b cube plus this is whole is nothing but b by v. Now it is v. So this is what power equation. Because we have previously we have seen the drag equation, and then this is the power equation, because the drag equation nothing but av square plus b by v square. So this is what this is what drag equation. So now the power equation becomes like this. So now suppose if we want to find out the minimum, then what we have to do, we have to differentiate this equation, and then we have to equate to 0, and then to get the minimum. That means so for finding minimum, just we can say that dp by dv. So this equation we are differentiating, so that is okay. We can just say that this is nothing but 3a v square minus b by v. So it means this will become b by v square. Okay, so this is equal to 0. So just because we are equating to 0, then to obtain the minimum power. So from this, what happened, we can find out what is the velocity at minimum power. So this is 3a square a v square minus b by v. So we can just equate this here. Okay, so b by v square. So this becomes v power v power 4 equal to now we can just say that b by 3a. This is what. Okay, so now we got the v, and v power 4. So that means this is minimum power. Okay, so we can just take it as this is minimum power. So minimum power equation further, this we can further modify this into minimum power equal to this whole power 1 by 4, because whatever was here v power 4, so that goes to other side, becomes 1 by 4. So now we got v by that means velocity at minimum power. Also we know velocity at minimum drag. Velocity at minimum drag, nothing but this is we can just say this equation. That means this is the so velocity at minimum drag is nothing but we can just say minimum velocity minimum drag, that is nothing but b by a. If you are just differentiating the equation, we will be getting b by 1 by 4. So this is that. Because that equation, this results comes from the our this one. Because we know drag equal to av square plus b by v square. So by using this equation we got because by differentiating this with respect to velocity, then we got velocity at minimum drag. So now we can just compare this and this. Because this and this, if you are comparing, so we can just say minimum power equal to b by 3a whole power 1 by 4. So by comparing these two, we can just now simplify. We can just say that 1 by 3 power 1 by 4. This is nothing but b by a power 1 by 4. So this is nothing but we can say as this is nothing but 3 power 1 by 4 into this one. So this is nothing but velocity. This is this term we are taking it as this one. So we can now it can be replaced velocity minimum drag. So velocity minimum power is equal to velocity minimum drag divided by 3 power 1 by 4. So now we can understand the velocity minimum power obviously will be smaller than velocity at minimum drag, because this 3 power 1 by 4 divided, because this term is dividing the velocity minimum drag. So because of that reason, the velocity minimum power obviously will be smaller than velocity at a minimum drag. This condition we can just understand or we can just put it in the equation or in the graph also, because the graph we can just put it because we can just say that this is we can just say this is the power versus velocity. So here we can just draw the graph. So it means it will be like this one, because the one is will be this one, this will be this one, another one will go like this, because one is okay, this is with respect to, we can just say v cube, and this is nothing but 1 by v. So this is the total power. Okay, so this is the total power. So now our minimum, okay, minimum velocity will be here. Okay, so this is what minimum velocity. So this minimum velocity, okay, will be smaller. Okay, minimum velocity, this point, okay, this point we can see as the v minimum drag. Okay, minimum power, this is at this one, this is okay, occurs at a minimum power minimum. Okay, so because this velocity obviously smaller. Okay, obviously smaller than this. So how much it is going to be smaller, so that we will see, because if you know the value of 3 power 1 by 4, okay, just then we can say this is okay. So velocity of the minimum power is nothing but it is equal to 0.76 VMD. Okay, so velocity at a minimum drag. So this is very important, okay, conclusion at this point. So because anyway, this also can be obtained from the CL and CD, based on CL and CD. So this is okay in the straight, okay, formula, or okay, straight equation we are getting. Okay, so velocity minimum power equal to 0.76 velocity at a minimum drag. So okay, I think this is clear. Now let us find the value. That means let us find the value of what to say, we just let us find the value of CL and okay, CL minimum power and CD minimum power, and then that is we can just from that also, by using that those value also, we can come to this conclusion. Okay, so that is one way. Now let us find the CL minimum power and CD minimum power. So CL minimum power and CD minimum power. So let us, okay, let it be here. Okay, let us keep it somewhere. Okay, so that velocity minimum power equal to 0.76 velocity minimum drag. Okay, so this is okay, we got it now okay, let's find the this one, CL minimum power and CD minimum power. So we just know, okay, from our previous equation or derivation also we have used. Okay, so drag equal to, generally when we say drag, okay, because power is nothing but drag into velocity, so we can just say this is yeah, drag equal to, just this we can write it as the yeah, drag into L by L. So at steady level flight, okay, we are replacing this lift equal to W. So by that way we can just see, okay, so this is at steady level flight, at steady level flight we can just say drag equal to drag into this W by L. So this further we can replace, or we can yeah, modify, that is nothing but W into D by L. Okay, D by L, or we can just say this also further can be modified, W into W divided by L by D. Okay, so this way also we can say. So let us keep this one, and then yeah, so drag equal to this. So now this we can convert into coefficient form also. So coefficient form also we can convert. So it means drag equal to, we can just say drag equal to this is nothing but W into CD, because this is nothing but CD of rho v square S by CL of rho v square S. So both will get terms will get cancelled. So this is, we are converting this into means CD by CL. Okay, so CD by CL, this is drag. So now, okay, now what happened, now we have to find the power, because this is only drag. Okay, this is, we have seen in our previous video also. Now, okay, we have to find the power. So power is nothing but P, that is equal to drag. Okay, drag into velocity. So because we are multiplying the drag with the velocity, then we are getting the power. So now here we have to multiply. Okay, so this is, so now what happened, we know the power velocity of the, that means the equation of the velocity. So this we can further modify, that means this we can say as the W into CD by CL. In this, V is nothing but square root of 2W by S by rho CL. So this is, okay, further we can simplify, and then we can just say that this is, okay. So yeah, okay, this we can further simplify. Is by simplifying this further, we get this one. So our P equal to yeah, so we can just say this one, W into CD by CL. Actually here one more CL is there, so this CD by CL into this one, we can take out that CL also, that is CL power 1 by 2. The rest of the term will be there as it is, that means 2 W by S by rho. So this term will be as it is. So now, okay, we can just say that P equal to W into CD, means CD by CL power 3 by 2, because this is CL power 1 plus 1 by 2. 1 plus 1 by 2, that means nothing but 3 by 2. Okay, so now we got this one, 2 W by S by rho. So now for finding the minimum, okay, for finding the minimum condition, only this term, okay, this term will change, because rest of the parameters, okay, or will remain constant. So if we want to just find the minimum, so this only this can, okay, have the minimum value. So for finding minimum value for this, now we can do the differentiation. So by doing the differentiation, so we can just get the this CL minimum power and the CD minimum power. So you can just say that for minimum, so for minimum, okay, just yeah, for minimum, so we can write dp by d, okay, because here the yeah, here the integrating factor is CL, so we can just say dCL. So it is equal to, now this is only this equation or this ratio alone we are going to take it. CD, we know CD is nothing but CD naught plus KCL square. Yeah, this is what, okay, we have to before that itself we can just replace. This is nothing but yeah, so CD naught, and just this term alone, this becomes CD naught plus KCL square whole divided by CL power 3 by 2. So this term only now we are going to differentiate. So by doing differentiation, so we just see there is means this power, this U by V formula we are using, so V square, so CL power this is nothing but 3 by 2 whole square, then CL yeah, I just we can say yeah, we can just CD naught plus KCL square, just we are okay, differentiating this term, so nothing but 3 by 2 CL power yeah, 3 by 2 minus 1, okay, so we can just say 3 by 2 minus 1, nothing but 1 by 2. So we just, or we can just say 3 by 2 minus 1, so this is 1 by 2, okay, so minus this term, okay, this term it will be as it is, okay. Now CL power 3 by 2, now we are differentiating this bracketed term. So this will become 2 KCl, 2 KCl. So this is okay, this is what equal to 0. Okay, by doing the differentiation and then finally, okay, so we'll just okay, we have to equate, and then by equating so from this, okay, what we will be getting, we'll be getting this one, that means KCl square, okay, equal to 3 CD naught. So this finally we will be obtaining this condition from this. So because from this further we can find out, we can find out, okay, CL square, because CL, okay, because this is for the minimum. Now we can say that this is minimum power, okay, KCl minimum power whole square equal to 3 CD naught. This is CL minimum power, it is equal to CD naught, 3 CD naught by K. So this is what, okay, maybe this is square root. So if you are just further we can simplify 3, okay, CL minimum power, it is equal to this 3 root 3 we can take it out, okay, root 3 if you are taking it out, then remaining term whatever is there, square root of CD naught by K, that is nothing but CL minimum drag. Okay, so if you want to we can keep it as it is, or okay, if you want to link with the minimum drag, okay, we can, this is. So this is the condition. Okay, so now let's see. Okay, now we got the CL minimum power, and CD minimum power also we can get it. So CD minimum power we can get from here. So CD minimum power nothing but is, so we know the CD equation, CD naught plus KCl square. So this, okay, when we say CD minimum power, this is also minimum power. So this KCl minimum power, that, okay, this is this term we are going to replace. So this is equal to CD naught plus 3 CD naught. Okay, so we just got the 3 CD minimum power equal to CD naught plus 3 CD naught. So this is nothing but 4 CD naught. So it means CD minimum power equal to this. Then we can just velocity minimum power also we can just say, that is nothing but square root of 2W by S by rho CL minimum power. So CL minimum power we can substitute then we can get the this one, because so velocity minimum power is nothing but this is 2W by S by rho. CL minimum power is nothing but what? CL minimum power is nothing but 3 CD naught by K. So this is, so from here also, because in the case of minimum velocity at a minimum drag, that will be equal to this one, only CD naught by K, but here we are having root 3. So that is what, root 3 again it is under this one. That is why we said this is nothing but okay, we can take this term, that means we can just say 3 power 1 by 4, then rest of the term will be there as it is. It means it will be like this, 2W by S by rho, so this is square root of CD naught by K. So this term will be there. Okay, so this is nothing but velocity minimum drag. Okay, so this is what I will say, velocity minimum drag divided by root 3. So this is, so this is velocity minimum power equal to, okay, velocity minimum drag divided by root 3. So this is what we said, 0.76. okay, or we can just say that it is 0.76 velocity minimum drag. Okay, so this is velocity minimum power equal to this is, okay, so this is what already we got it from the direct equation. Okay, by differentiating we got it. I think from in both the ways we have proved that velocity minimum power equal to 0.76 velocity minimum drag.